Good morning, everyone. Um, it's going to be a bit of a one-way presentation because I don't hear anything from your side. I do see a lot of participants. I'd like to welcome you on behalf of the capacity building team. We're running a little bit behind the schedule, so we're going to do the presentations a bit faster than we may have planned. And I may have to skip also the presentation of the setup of the training as a whole. Let me just this. Right. So for our first presentations of today and tomorrow morning, we've had some translations made of the training materials. So everything that will be shown, well, nearly everything that will be shown will be translated to Portuguese. Us trainers will speak in English. We really hope that at least the big majority of you can understand as well. If there's any questions, we ask you to remember them so that we can discuss maybe in the last bit of each of the sessions. We'll try to terminate just a few minutes in advance so we can have some exchanges. So what we want to start with today is to discuss a little bit the wider context of energy. I do believe that some of the honorable speakers this morning have addressed the issue of the importance of energy, and that's something that we would like to have a bit of a closer look at before we actually get into more detail and more depth in the different renewable energy technologies and applications that we will be talking about during our capacity building sessions. So basically what we would be talking about is basically the global energy trends and what we see in the world around us, which countries play the largest role in consumption and production of energy. We'd like to address the major environmental issue of greenhouse gas. And then we switch with a look at renewable energies, and then focusing a bit on the three major sources of renewable energy: solar, hydro, and bioenergy. And lastly, Dr. Carlos Lucas will have a small session on renewable energy in Mozambique. I did have some questions for the audience, also to test a bit the let's say the two-way communication and the way in which we can interact, and let's say you as audience can pose your questions, and we can pose our questions and see if there's answers. But due to the time limitation, I think it might be better if we skip that one. So starting here, I think, like I said, one of the speakers this morning indicated that energy is an extremely important subject in society. Not only it's a basic need, just you know, for preparing food, keeping us warm. Let's say apart from needing energy from food for living, for our bodies to function, to heat itself, and for us to be able to move. But energy is also a key driver for development. I think over the last centuries, we've seen that with let's say the modernization of our energy supply, also development followed, and that is, economic development, productivity, being able to produce more efficiently. If you're not limited to having your human power, you can greatly improve your productivity as a person, as a society. That's on the one hand, but also for improving living conditions for people. And of course, we're thinking about rural areas, for example, where there's so many people who don't have access to modern energy. And that means that in their daily life they have to rely on let's say traditional energy sources, firewood, for example, kerosene for lighting, candles, more and more switching to torches, batteries. And for production, it's mainly human power and some animal power, and that's a great barrier for development. Speaking of, we should be talking about energy poverty, which we could define as a lack of access to modern energy. Let's say the situation that just pointed out, and the dependence on low quality energy sources. If I say low quality, I don't really mean the quality as such, but more, let's say, in contradiction to modern energy sources, clean energy, that do not cause, let's say, indoor air pollution, for example. What is an important aspect here is that it's so difficult for people to get out of a situation where let's say a traditional inefficient energy supply is actually a barrier for getting out of that situation. If people are relying on their human power for agriculture, for example, for looking for firewood, which can take a lot of time in a day, and that's time that cannot be spent on other productive activities, and that is one of the mechanisms that's keeping people back in their development. Now, if we look at the situation in worldwide, we see that energy supply has been increasing continuously, more or less continuously. We do see that there's a little dent here that was due to a financial crisis in 2008, 2009. But well, we quickly caught up, all of us on this planet, and from 1990 up to 2018, it's been increasing and increasing. What we do see is that oil, the big growth in oil is slowing down a little bit. We do see that coal is increasing, natural gas is increasing, nuclear is quite stable, and that renewables are, especially in the last, say, 10 years or so, are really starting to increase. We look at the main producing countries of energy, then that's China, US, and Russia, to some extent EU and Saudi Arabia. And well, as we saw in the previous slide, it's still mainly fossil fuels, coal, oil and gas, and in Europe the share of nuclear and biofuels is rapidly increasing. if you look at where the actual consumption of energy is taking place and how that is growing, then we should conclude that especially China is a major grower. Particularly looking at the period of 2000 to 2010, and their energy consumption more or less doubled. And that is, of course, because of their economic developments, their increase in production, their position as a major exporter to all of the world, them being the the world's workshop, as we call it. And of course, it continues to increase even over the last 10 years. What we see in what were originally the big consumers, US and EU, that has steadied to some extent, and that is also due to increasing energy efficiency, reducing say the energy consumption per unit of production output. If you look at the energy consumption per capita, so per person in a country, you see very big differences, of course. What's striking is that the US really takes a lead, but at the same time, between 2000 and 2015, their consumption per capita has decreased. We see the same level of decrease in the EU, although the starting position is only half of what it is in the US. On the other hand, in China, we see there's been a doubling of per capita energy consumption. And that is, of course, in line with what we saw in the previous graph. As you see in Africa, that it's more or less stable, and that is on the one hand because of the large growth of energy consumption is more or less in parallel with the population growth. So it's in the end the consumption per capita remains stable. And looking at Mozambique, we see that even though there is a energy consumption growth over the years, it's been lower than the population growth. So that means that if you look at the energy consumption per capita in Mozambique, it's actually been on the decline in the last 10 to 15 years. Now, if we look at the CO2 emissions from fuel combustion, and those CO2 emissions are the largest quantities. Others being, let's say, from agriculture, particularly. We see quite similar countries appearing in the top 5, being China, US, and EU, with China being the biggest by far. But you also see India, which of course has an immense population, which is why their consumption and emission is so big. And we see Russia appearing as well. And these are figures for 2018. I think these are still quite valid. Now, if we look at the different sources or the different growth figures from the different regions, we see again that China has shown a tremendous growth, especially in the period of 2000-2010. We see that US and EU have been quite stable, or even decreasing a little bit. and that Africa, although it's still only a very small portion of the total, is increasing as well. And unfortunately, if we look at the world emissions of CO2 from fuels, we still see that it's never declined over the last 30 years or so. It's showing a slowdown over the last 5 years or so. But it's really something that we should realize that all of us all over the world should work harder to turn the trend around if we really want to keep the CO2 emission limits to acceptable levels. I'm sure that you all know the systematic, let's say, the problem with CO2 emissions, greenhouse gas emissions, being the major cause of global warming. The greenhouse effect caused by particularly CO2 and methane, CH4, causes the radiation of heat from the Earth's surface to sort of be retained within the Earth's atmosphere. Whereas, you know, if the concentration of greenhouse gases is lower, than most of this radiation is radiated into space. But because of the increase of the concentration of greenhouse gases, a larger part of this radiation is contained, which causes the overall temperature in the world to increase. And of course, not only that, also changing the weather patterns. So let's say weather all over the world will get more extreme. So let's say dry areas may get more dry, wet areas may get wetter. And of course, in addition to that, we have the problem of rising sea levels, that especially countries with sea borders, including Mozambique, of course, could be problematic in the future. Now, looking in historical perspective, we see that the emissions of greenhouse gases have been increasing in most of the years. What is quite striking to me, at least, is to see that the effect of the global pandemic that we are facing now is really huge, and that is of course because of the economic slowdown of the economic systems around the world. Reduction of traffic, international air traffic, reduction of energy consumption because of reduced output. And even though, you know, this large quantity should be seen in the in context of the current emissions that we have right now, but this reduction is in the order of let's say 5 to 10% of the total emission that we have around the world right now, and that is quite comparable actually to the reduction that we saw during the Second World War. There as well, and the slowdown of the economy has caused reductions of roughly 5 to 10%. Now we're of course all working very hard to reduce our CO2, our greenhouse gas emissions, and of course one of the major ways that we're doing that is by increasing our renewable energy production. And there, if we have another look at which of the countries are doing the most of that, then we again see China and EU and India and the US appear in the top 5. And it's important to realize that most of this is due to the use of biofuels and wastes. And if I say biofuels and waste, then it's actually still a very large quantity of biofuels, woody biofuels, traditional biofuels that are being used for cooking. That is especially so for India, for example, but also in China. What you see in the EU is that there's more and more production of electricity from organic matter, and that's mainly biogas and also solid biomass, and especially in the US and also in Brazil, it's mainly ethanol for the production of biofuels for automotive fuels. It's of course not just an effort of countries and regions within the UN. Let's say there's major efforts to let's say improve the worldwide development in a sustainable manner, and let's say energy, renewable energy, and climate change are an important aspect. There are, out of the 17 Sustainable Development Goals, there's 2 of them that relate directly to renewable energy, and that is let's say the development goal number 7, ensuring access to affordable, reliable, sustainable, and modern energy for all. And there is Sustainable Development Goal number 13, taking urgent action to combat climate change and its impact. So those are directly related to energy, to renewable energy, and to reducing the emission of greenhouse gases. But there's also other sustainable development goals that have underlying relations with the way that we produce and consume energy. For example, Sustainable Development Goal number 9 is about infrastructure and how industrialization and innovation should be more inclusive and sustainable. Development Goals 11 about cities, 12 about responsible consumption and production, rationalizing that the consumption of fossil fuels are all related to the way that we sort our energy supply. The way that we should be attaining, let's say, a more sustainable energy supply and reducing our greenhouse gas emissions is mainly based on 3 pillars. That's increasing the energy efficiency, and then we're talking mainly about industry, transport, energy consumption in buildings, heating and air conditioning. Secondly, that's renewable energy, and that is well, of course, the way that we produce our electricity, but also our heat and our transport fuels. And then there is, let's say, carbon capture, utilization, and storage, There is behavior change of people. There's resource efficiency, and that's in this third pillar. And all three of them are required to actually get to where we need to go in order to limit the overall temperature increases on the planet. We discussed during the Conference of Parties COP, which number it was in Paris some years back. Discussed that we should well, definitely make sure that we remain below the 2-degree temperature increases around the world, and we should make the best possible efforts to keep it at 1.5 degrees maximum. That's how this scenario was developed by the International Energy Agency. Renewable energy introduction, it has great opportunities, and it has some barriers. So looking at opportunities, we see that the costs, the production costs, and the investments required for renewable energy have been going down over the years, and that's for very large parts due to innovation and mass production. I think that's particularly solar energy has benefited greatly from these two aspects of the last 10-15 years. A second opportunity is let's say economic advantages, and that's not just the let's say the financial view on renewables, on changing our energy from fossil to renewables, but it's really on a country basis. Let's say renewables can permit countries to have a much larger stake in their energy production by let's say utilizing energy sources that are available in the country by using their own waste, for example, their own hydro resources, and thereby becoming less dependent on fossil fuel imports like oil or coal that is being produced in you know just a few handfuls of countries around the world, and that means that, you know, utilizing more of the natural resources has some clear economic benefits for countries. Say less imports, increasing their own production is a stable way of increasing the GDP. The domestic products of a country. Well, of course, instead of being dependent on a small number of countries that produce the energy that we consume worldwide, we get a more equitable energy supply, whereby, you know, both the solar, hydro, biomass, but also wind and to some extent the geothermal energy production is divided in a more equitable way. And of course, there's additional environmental advantages. It's not just the greenhouse gas emissions that are reduced. It's also the let's say in cities the problems with smog. Which is directly related to the emissions of let's say internal combustion engines and industries, in combination with let's say weather conditions. And there's oil spills related to the way that we move around our energy carriers. There's been a few very big ones over the last 10 years, but there's smaller ones on a more continuous basis. And by reducing the requirements of fuel transports, we also reduce the risks of spills occurring. I'd like to give the floor to my colleague Paul right now. Let me see if I can. Paul, can you hear me?
Yes.
Okay. I think it's perhaps easiest if I.
Can everybody hear me well? Yes.
Must be. I hear you at least, so I suppose that the whole system.
All right. So yes, good morning, ladies and gentlemen. Very briefly, continuing on what Bart was saying, in terms of solar energy, we can see that there has been a tremendous increase in the cumulative power capacity being installed.
Hello, Paul.
The world.
Paul,
Yes.
we cannot hear you.
No.
Yes, get closer to your mic. I think it's important.
Hello. Cannot hear me now?
Yeah, this is better.
Is it better?
Yes.
Okay, good. And what about in the room? Is it okay?
Yeah, is everything okay here as well?
Okay, good. Thank you. So yeah, as you can see in the picture in the slide, in the recent years there has been an increase by a number factor of 3 from the overall photovoltaic capacity installed in the world. Especially we have seen an increase in Asia, in Asian countries, but also not to minimize the increase that we are starting to see in some African countries. It's a very faint line in the bottom, the orange one below the blue, but you can see that the African photovoltaic capacity is already present there in the last 5 years. Can you move to the next slide, please?
Oh, sorry.
Okay, thank you. In terms of the kind of technology in the photovoltaic modules, related to photovoltaic modules, at the moment, the market is mostly dominated by the crystalline silicon technologies, yeah, either multi-crystalline or polycrystalline also called, or the monocrystalline, yeah. Together, these two PV module technologies, at the moment, they account for almost 90%, yes, of the world market. Meaning that in 9 in every 10 PV systems we will find in the world will probably have crystalline PV modules, right? The remainder being what we call the thin film technologies, okay, which are, we will see that in the later stages in the course. Tomorrow we have a session on the PV modules, where I will share with you a lot of details of the advantages, disadvantages of these technologies, okay? But the reality is that, at least for the PV module generation side, the market is mostly dominated by the crystalline technologies, okay? Next slide, please, Bart. At the same time, yeah, solar energy, solar photovoltaics is a very versatile technology. Here in the audience in the room, I'm sure that you are familiar with this quality of photovoltaic technology. Yeah, from very basic small systems, solar lanterns, pico systems as they call them, to growing in capacity to deliver kilowatts, even megawatts of power through via PV farms or solar parks connected to the grid. So yes, photovoltaics has always been a modular and a flexible technology, and this tendency is very much appreciated and growing at the present and in the near future. Yes. Next one, please. At the same time, a very important tendency we can see for solar energy has been the decrease in the price, in the cost. In this chart, we can see the comparison of different technologies. This is more or less a general trend for renewable energy. Yes, it's not only a quality that we can see for solar photovoltaics, also for hydro, for other technologies. But you can see in the middle, yes, solar photovoltaic between 2010 and 2019, an impressive decrease of the average cost, yes, in dollars per kilowatt hour. Obviously, this tendency has generated a lot of interest, a lot of market opportunities for solar photovoltaic. You can see it is a decrease from 0.4 more or less dollar kilowatt hour to 0.07. Okay, that is a reduction by a factor of 6 in the average cost. So prices are coming down, and this is really, really very good news for solar energy. Next one, please. Finally, I wanted to have draw your attention to what could be the split, yes, of the costs. These costs that are reducing, that I mentioned. Obviously, inside the PV system, not everything is down to the PV modules. We have many other elements, many other components. And in this slide, you can see this is coming from a report from the European Union. What could be more or less a typical breakdown for large PV systems, what we call utility scale PV systems, like the ones that were mentioned in the introduction, like Macumba site, for instance. Typically, what we see is that the PV module costs are roughly 29% of all the PV system cost. Yes, that's the generation cost. And an equally important fraction of all the solar system cost is the engineering, the procurement, and the construction cost. In other words, this capacity building course we are doing here is very much indicated because it has to provide the tools, yes, for institutions like yourselves to be able to deal with one of the parts of building and designing a PV system that ends up being retaining most of the cost, most of the difficulties in a PV system. Equally important as the generation side of the system. Okay. Yes. So the procurement and construction, the logistics, these are parts of a solar PV project that are difficult. The knowledge there is very important. Okay. Other parts of the cost, of course, the batteries or the inverters or the transformers, etc., do also have a share in the overall cost. But you can see that the generation side and the engineering, procurement, and construction together almost account for half of the costs of a PV system. Yes. Thank you. The next one. Yes, that's for Divas then. Thank you.
Thank you, Paul. Divas?
Yes, I'm ready. Can you hear me, please?
I can. How about
okay.
your room?
Carlos, can you hear me? Hello, Carlos. Can you hear me in the room, the training room?
Yes.
Okay, thank you very much. Yeah, thank you, Bart, and thank you, Paul. I think they have set a very good background for the introduction of renewable energy, and hydropower is considered one of the important source of renewable energy. Although there are certain concerns about large hydros, but small and mini hydros are very much considered. I mean, it is renewable, but it also meets the other criteria of renewable energy. Let me first give you an overall status of the installed capacity and the energy generation from hydro, according to the data of International Hydropower Association in 2019. Africa, for the matter, has the lowest capacity, installed capacity, as well as the lowest energy generation from hydropower in terms of the global capacity of 1,300 plus gigawatt and 4,300 plus terawatt hours of energy generation. But Africa is said to have a huge potential. So the future in Africa, we expect to see more development of hydropower, medium large, as well as small and mini hydros and micro hydros. In terms of, I just wanted to, I'm sure most of you are familiar with this, but I just wanted to share that Mozambique at the moment ranks as the 7th country in Africa, with the 7th largest, 7th in terms of rank, in terms of installed capacity. But I think you have to bear in mind that the majority of this 2,216 megawatt of installed capacity of hydropower comes from the Kahora Bassa dam, which produces 2,075 megawatt. So there are other smaller, I think there are projects in the range of 50 and smaller and mini hydro projects that that constitute the other parts of the Mozambique hydropower installed capacity. But I'm told that there is a huge potential of around 20,000 megawatt. And this might be, I think, the participants would know better on that. But from the information I have, there is a huge potential and there's a plan for hydro development along with other renewable energy in Mozambique. Next slide, please. Sorry. Yes. And in terms of, I just wanted to give a picture, just compare the hydro installed capacity and the energy generation from hydro compared to other renewable energy. I would just like to point out here that this hydro capacity includes large hydro, and there is some issues about some countries have not, do not really consider large hydros with reservoirs as completely within the renewable energy technology domain. Although mainly because of the environmental and social issues connected with large hydros, especially with reservoirs and especially with hydro projects that divert water from one river to another or leave a part of the river dry for a certain period of time because of regulation as well as transfer of water. There are also issues about greenhouse gas emissions from the manufacturing, the cement used and other infrastructure necessary for hydro. Nevertheless, hydro power is a clean source of energy and it is renewable. So it is, at the moment, there is in terms of other solar and other wind and other bioenergy, the hydro capacity and energy generation constitute a good percentage. But this will change. It will change as Paul and Bart presented. The future of clean energy, renewable energy, we'll also see a lot of a good increase in other renewable energy, solar, bioenergy, and wind. Next slide, please. Yes, in terms of Mozambique, I got this information from a report from the International Renewable Energy Agency. So this might just give you a picture, like this is an off-grid hydro and solar. So when I talk about, these are basically not grid connected energy supply. So in terms of installed capacity, from the information that was given in the International Renewable Energy, 15 megawatt of solar energy was being generated, and around little more than 1 megawatt of hydro energy installed capacity was in place. But in terms of energy, because hydro, especially this off-grid, has a higher capacity factor, which means that the average energy and the peak generation, the ratio is a little bit higher than solar. So you see this trend. Of course, this is just to give you an example of how hydro is providing off-grid energy in Mozambique. And these figures are from the IRENA report, and it is subject to verification by the participants, but I just wanted to show you this. So in terms of Africa as a continent, it also has a good electricity generation from hydro as well as from solar. So this is a good combination of hydro with other renewable energy is also a factor that we need to consider. Next slide, please. Yes. Now, this is one, I just wanted to give a trend of what hydro's role would be in the electricity generation of the future. And Bart mentioned about the Paris Agreement, which has set a target of, in fact, aiming to not to limit the increase in temperature to 1.5 degrees Celsius up by 2100 compared to the pre-industrial period, but not to exceed more than 2-degree rise in temperature. But for that, as Bart has already mentioned, renewable energy and other policy interventions, drastic interventions are necessary. And the International Renewable Energy Agency has developed 2 scenarios. Although the Paris Agreement and also the different countries have set up what they call a national commitment for how to reduce this, how to limit their greenhouse gas emissions. And according to that, IRENA has developed 2 scenarios. One is called the Plan Energy Scenario. This is the scenario based on different countries' commitment, national commitment to reduce greenhouse gas emission. And this is the scenario that is based on the policy, the present policy adopted by different countries. Whereas IRENA, according to the analysis of the renewable energy agencies and other agencies, they do not think that the planned energy scenario will really lead to a reduction on greenhouse gas emission that would limit the temperature rise to 1.5 or 2 degrees. So they have proposed a more transforming energy scenario, in short called the TS and PS, where the share of renewable energy has to drastically increase compared to the non-renewable fossil fuel and other energy sources. So if you see this, I actually took an example of solar photovoltaic and hydro, and also there are other renewables. And if you see this in 2017, non-renewable energy sources constitute 74%, a huge percentage in terms of energy generation. And in terms of installed capacity, it consists of 66%. Whereas solar photovoltaic is just 1%. But in terms of energy generation, the planned energy scenario, it will rise to 13%, and it will rise in the transforming energy scenario, it will rise to 35% with the total energy generation ratio. Whereas in terms of capacity from 3 to 29 and 50. Now, hydro, the reason I show hydro in relation to other renewable energy, especially solar here, is hydro still has a major role to play in meeting the Paris Agreement, especially limiting the rise in temperature to less than 2 degrees. For example, currently the energy generation is about 22%. In the planned energy scenario, it will be 18. In the TS, it will be 20% in terms of energy. In terms of capacity, it will be 25, 18, and 19. These are relative terms. In terms of absolute installed capacity, absolute energy generation, hydro would increase. although over here it is showing a more or less the same ratio. This is because other non-renewable energy sources like solar, bioenergy, which are given other renewables, that will also increase. So this is just a scenario of what hydro has to, is expected to play in terms of meeting the Paris Agreement. Next slide, please. Yeah. Now, this just to sum it up, hydropower is an important source of renewable energy that is expected to bring synergy to the energy system of the future. As it was mentioned by the other previous speakers, renewable energy is going to play a major role in the energy mix, and hydropower has an important role to play. The reason being, it is a mature, reliable, cost-effective, renewable energy technology. It integrates very well with variable renewable energy like solar and wind. Like when the sun does not shine or the wind doesn't blow, you would need other storage, other sources of renewable energy that has to complement and to bring, like especially in the grid stabilization, as well as to bring reliability in the energy supply. Hydropower also has multiple benefits. It provides other benefits such as irrigation, water supply. So this is the reason hydropower will have an important role. It is flexible in design. For example, it can be designed with a very high capacity factor to meet the base load, as well as at a lower capacity factor to meet the peak load. And by capacity factor, I'm sure most of you are familiar with the capacity factor indicator, which means this is the average generation divided by the peak generation or the peak installed capacity. So higher capacity factor means the generation is more or less same throughout the period, day or a year. A lower capacity factor means it generates in a higher capacity at certain time of the day, month, or year, and other times it generates at a lower capacity. Similarly, new hydropower and modernization is expected to increase by 2/3 capacity. Currently, it is 1,300 gigawatt hour. It is expected to increase to more than 2,000 gigawatt hour by 2050. And there will be a 850 gigawatt hour new capacity by 2050, including pump storage, which will double to 325 gigawatt hour. These are the indicators. That was the hydro trend that was given by IRENA, and this is the PS, meaning the planned energy scenario, and the transforming energy scenario, where hydropower is expected to rise. The capacity is expected to increase. Similarly, there will be a major role of pumped hydro storage. Pumped hydro storage are hydropower projects which sort of water is pumped backwards when there are extra energy in the grid from renewable energy sources, other sources. So you can pump. It's like basically it acts like a energy storage system, which will be very useful to integrate hydropower, pumped hydro storage with other renewable energy sources, especially in the grid connected systems. I think for now, that's all on hydropower. Thank you, Bart.
Okay, thank you, Paul. Then we continue on the trends in bioenergy. If we look at what bioenergy entails these days, then we see that by far most of the bioenergy sources are represented by solid biomass, and within solid biomass, a very large percentage is used in buildings, and in buildings we mean basically for heating and cooking. And then if we zoom in on the buildings, we see that a traditional use of solid biomass, so that's basically fuel wood used for cooking, is a very big share. We do see that there's substantial amounts of solid biomass also used in industry and for the production of power and heat in large plants in different parts of the world. We see that there's a smaller portion of bioenergy used in the form of transport fuels. And that's particularly ethanol and biodiesel. And that there's some quantities under other, and that's mainly transformation to other biofuels like charcoal. But just to indicate that so far we're mainly looking at solid biomass if we talk about bioenergy. That means if 85% of all bioenergy is represented by solid biomass, looking at that, substantial part of this is consumed in Africa, and this quantity is growing with approximately 2.5% per year over the last 10 years or so. And that is substantially faster than the annual growth overall over the world. That is less than 1%. And looking back at China, which presently has roughly 5% of the solid biomass consumption, this has been on the decrease over the last 10 years. So mainly because they're moving away from let's say the traditional use of bioenergy. The solid biomass used in households, residential energy, and that's mainly cooking fuel, and to some extent also for space heating in the say the colder climates. We see that there's a decline as well, a reduction over time. On the other hand, looking at the modern larger scale use of solid biomass in electricity and heating plants, that is growing quite rapidly, especially in Europe. It's been increasing. Looking at biogas, it's in relation to the total. It's still quite modest. The share. The total was just a few percent. In absolute terms, 33 million tons of oil equivalent. And most of that is produced from crop residues and municipal waste as feedstocks. Looking at the end use of biogas, we see that about 1/4 is used for domestic energy. That's for the largest part. That's household systems found in Asia and to some extent in Africa. But the larger part is used for the production of electricity and heat in the CHP plants. And that again is mainly in Europe and the United States. Although let's say larger CHP plants in other parts of the world are increasing quite rapidly. If we see that the share of biogas in total has been growing with about 4% in the last 10 years. Right now, the production capacity is about 18 gigawatts, and that is it's an increase that will increase its share further. What we see again, especially in Europe, is a very big tendency to move away from CHP and convert more and more biogas to biomethane. Right now, that's roughly 10% of the total. Say, looking at the biogas plants that are installed today, a really substantial part of them convert the biogas to methane to be injected in the natural gas grids that are available in many countries. And looking at Africa, the biogas sector, even though it is emerging in more and more countries, it's still a very small part, but its growth over the last 10 years has been quite spectacular, with more than 8%. So that is also something where we expect large increases in the years ahead. For liquid biofuels, I believe that this is also something that is starting to take hold in Mozambique, particularly for household fuels, ethanol as cooking fuel. It's substantial, especially in the United States and Brazil, where bioethanol is produced, mainly from corn, from maize in the US, and from sugarcane in Brazil. On the other hand, we have biodiesel as a liquid biofuel, which is mainly produced in Europe and South America. In Europe, mainly from, let's say, locally grown oil crops. In South America, mainly from soybean oil, and there's increasing quantities of biofuels, liquid biofuels, by other means produced. That's for example hydrotreated vegetable oils and biomass to liquid, which is mainly produced by thermochemical production. That is something that we will be looking at during the training as well in one of the sessions. Bioenergy these days, there's growing concerns about the sustainability of the biomass resources, and there's very big debates ongoing, at least in my country, but also in other countries, that it's highly important to avoid the exploitation of biomass resources to lead to deforestation. We've seen some years ago that large quantities of palm oil, for example, were transported to Europe for the production of biodiesel, and that is a trend that was reversed. That's also because the enormous demand creates a large supply, especially in Southeast Asia, and new plantations for palm oil were particularly planted in forested areas, and that led to deforestation to a large extent. Also, some years ago, there were some cases where a large demand of oils, but also, let's say, starchy crops for the production of ethanol, may have been leading to increases in food prices. There was a big debate on food versus fuel, whether we should be using crops, oil crops, starch crops, sugar crops for the production of biofuels. That discussion has reduced a bit, but it's still ongoing here and there. Land grabbing is an important thing that's, I believe, also in Mozambique. It's been an issue at some point. I know that in several other African countries, at least, it has been. Ethiopia, at least. And then there's the issue of what we call the carbon debt by using non-waste biomass, meaning that consuming solid biomass, it will take quite some years before the CO2 emitted by the use of this biomass is actually reabsorbed by, let's say, new growing plants. That there's quite some debate on whether biomass, solid biomass, non-waste biomass can be actually considered renewable in the same way as solar, hydro, and wind, for example. I'd like to ask Dr. Carlos Lucas to speak on renewable energy trends in Mozambique.
Thank you, Bart. Can you hear me?
Yes, faintly, but I can hear you, yes.
Thank you very much. Now you have to learn some Portuguese because I will.
I will.
This last part of the presentation about the overview of the of the renewable energy.
But Dr. Lucas, we can't hear you.
You can't hear me.
No. Maybe.
You want me to take out the mask?
No, it's for your protection, but just maybe speak louder.
Can you hear me now?
Yes.
Oh, okay. No, I was saying that this last part will be just dedicated for Mozambique part or example. We'll be talking about all renewables we have heard this morning, and I will take it in Portuguese so that my colleagues will rest a little bit before we go to lunch. Is it okay for you then, Bart, Paul, and Divas?
Yes, of course. I think it's better for the audience.
Sim, claro.
Thank you. Bom, eu dizia que esta última parte é simples, porque é uma parte que todos os colegas que estão aqui têm conhecimento. Pode ser que um número e outro não tenham, que nós fomos recolher e trazemos aqui, mas o resumo inicial é que nós trazemos para aqui somente as três partes que vão ser estudadas, que é a energia solar, a hídrica e bioenergia. Estamos a falar de eólica e outras, mas obviamente o país tem essas outras formas de energia. No caso de energia solar, como podemos ver, o país é muito rico. A maior parte de bioenergia, de renováveis de Moçambique é energia solar. É um estudo que foi feito pelo FUNAI em 2013 e 2014, um estudo que existe na internet. No fim, todos os colegas vão receber essas apresentações, mas na parte final vem a lista de bibliografia. Nós indicamos onde fomos tirar a informação. É só ir à internet, clicar. Esta informação que estamos a mostrar está disponível. Obviamente, tem mais informação do que esta, mas esta custa muito mais dinheiro para obtê-la. Se está aqui alguém
para aumentar o som, por favor.
Testemunhar o que estou a dizer, ou se estiverem os colegas lá em cima. Então, o que está indicado na tabela mostra claramente que, em termos de energia, em termos de gigawatts, temos para a energia solar 23 mil, comparado, por exemplo, com biomassa, que é apenas 2 gigawatts. Portanto, são dados recolhidos pelo FUNAI e que indicam, por outro lado, que temos, sim, potencial na energia eólica, temos potencial na energia hídrica, mas, como podem ver, a maior participação em termos de potencial é a energia solar. Next slide, please.
Mhm. Carlos, can we check if the audio in room 2 is okay?
Yeah, it's okay. So everyone could hear me. No problem.
Yeah. In the other room as well?
Yes.
Okay, okay. No problem.
Thank you. Thank you. O próximo slide mostra quais são, qual é o potencial da energia hídrica e, sobretudo, falando das mini hídricas. Aqui o FUNAI não fala das grandes barragens, Cabora Bassa e outras, mas fala daquilo que nós podemos aproveitar para produzir energia elétrica na forma de pequenos centrais e também para aquilo que chamamos de energia elétrica off-grid, a possibilidade de forma isolada, podermos fornecer energia ao longo de todo o país. Para deixar todo o país representado, vamos ver que a zona sul do país, de Inhambane para baixo, temos poucas possibilidades de usar esta forma de energia, mas a concentração verifica-se mais no centro e para o norte do país. Portanto, estamos a falar de Tete, Zambésia, Nampula, a subir para Cabo Delgado e Niassa. E o FUNAI também, para além de ter tido possibilidade de fazer este levantamento, fez uma simulação de projetos e indica, portanto, quais são os projetos que podem ser prioritários, quais os que não podem ser. Ao longo do curso que vamos discutir, vamos pegar em alguns exemplos do que realmente está acontecendo no país e simular os cálculos, que é para os colegas poderem acompanhar melhor esses números todos que aparecem aqui. Next slide, please. Next is the same, this one. Next, this is still hydro, okay. Queria dizer que em termos de biomassa, o mesmo trabalho foi feito pelo FUNAI. Lembremos-nos, biomassa contribui apenas com 2 gigawatts de potencial de energia, mas podemos ver a distribuição que é indicada do ponto de vista de quais são as províncias que oferecem maior potencial de bioenergia, neste caso de biomassa, concretamente. E reparamos que a Zambésia é onde há maior potencial. Temos a distribuição de norte a sul ou de sul a norte, e vimos também que, por exemplo, a província de Maputo e cidade representam muito pouco em termos de contribuição. Mas se formos a ver a parte que está indicada em amarelo, iremos reparar que há muito potencial de uso de biomassa na zona sul do país, porque é onde se encontra a maior zona urbana e suburbana do país. E essas zonas usam mais biomassa, como vimos nas apresentações dos meus colegas, usam mais biomassa, que é a energia tradicional mais usada neste país para o setor doméstico e para o setor industrial. Ora, o FUNAI mostra também que há potencial para a biomassa não ser originária apenas da biomassa tradicional, ou seja, da lenha e carvão vegetal, mas também é possível obtê-la a partir de indústrias. E, no caso, temos um exemplo que o FUNAI traz, que a indústria açucareira, em geral, sabemos que as indústrias açucareiras são distribuídas do centro a sul do país. A indústria açucareira, em geral, pode contribuir também para a produção de biomassa. Ao longo do curso, mais uma vez, teremos aqui alguém de uma empresa que vem falar exatamente de como é que isto está a acontecer nas indústrias açucareiras. Next, please. Este exemplo que está aqui é mais para mostrar que, enquanto a eletricidade de Moçambique, o gráfico que está ali indicado, mostra a tendência de produção de energia elétrica mais ou menos até o ano 2050, 2030, 2050, esta tendência de produção de energia elétrica, infelizmente, não está a ser acompanhada por um crescimento adequado da tendência de uso de renováveis. Então, como nós já ouvimos esta manhã, há um esforço muito grande por parte do governo para que até 2042 a capacidade instalada no país para a produção de energia elétrica considere uma parte de energias renováveis, sobretudo a energia solar e a energia hídrica. Não há aqui indicação de grande utilização de energias renováveis do ponto de vista de biomassa. Mas há também uma parte de contribuição de energia eólica que se espera que seja desenvolvida nos próximos anos. Next, please. Aqui é mais um exemplo. Este é fornecido por um dos relatórios que é dado pela IREN, que é a Agência Internacional de Energias Renováveis, que mostra claramente que este país, mais outros países, mais a seguir podemos ver, mas este país tem um outro potencial não aproveitado. O outro potencial não aproveitado é a biomassa que provém da agricultura. Quando fazemos o agroprocessamento, o que sai, que é casca, por exemplo, da mandioca, e também os outros desperdícios que saem da mandioca, podem ser aproveitados para a geração de energia térmica e energia elétrica. Mostra também a lista, a primeira coluna lá, mostra quais são por assim dizer, os produtos alimentares que o país produz. E como nós sabemos, o governo neste momento está a promover o agroprocessamento. Significa que os números que a Agência Internacional de Energia mostra aqui podem ser diferentes daqui a 1 ou 2 anos. Os números que nós temos aqui foram tirados em 2010, 2014, e há uma projeção para que até 2050 os números cresçam. Portanto, o que nós vemos aqui neste diagrama é que temos 2010, 2030 e 2050. Mostra claramente a tendência de aproveitamento de biomassa nos próximos tempos, ou melhor, até 2050. Mas cálculos feitos não com base naquilo que o sustenta em 2021 vai produzir. Em 2020 começamos o sustenta, em 2021 vamos ver resultados que podem alterar este cenário completamente. O que é muito ideal, porque o país, como sabemos, é muito rico em produtos alimentares, em termos da sua produção, e não só, por exemplo, a produção do algodão, que acontece muito para o centro e norte do país, e sobretudo na zona norte, aparece também como uma das fontes futuras de energia que este país tem que começar a considerar. Portanto, repito, o que vai acontecer é que, muito provavelmente, a quantidade de energia que nós vamos usar nos próximos tempos, muito breve, se formos bem-sucedidos com sustenta, por exemplo, o aumento de resíduos da agricultura, do agroprocessamento, vai proporcionar um aumento de produção de energia térmica e energia elétrica. Por exemplo, mais uma vez, as indústrias do açúcar são as que neste momento estão a aproveitar isto, os colegas da EDM sabem melhor do que eu, que há a produção de energia térmica e elétrica. E as indústrias açucareiras de Moçambique, poucas, usam a energia da EDM. Usam, por exemplo, como é sazonal a produção do açúcar, no período em que não há produção de açúcar, então recorre-se muito à rede da EDM. No período em que há uma alta produção de açúcar, então a EDM, em princípio, devia comprar a energia das açucareiras. Mas havemos de ouvir ainda esta semana como é que efetivamente está a acontecer já na prática no país. Next slide, please. Next. Ok. Nós quisemos trazer aqui para visualizarmos em termos de biomassa o que é que está a acontecer em África, e nós vamos ver Gana, Moçambique, Nigéria, África do Sul, Uganda e o mundo em geral. Os números do mundo em geral já foram apresentados por meus colegas, eu só queria trazer aqui a diferenciação. Então, podemos ver claramente que a produção de resíduos, ali a vermelho, a produção de resíduos pode atingir cerca de 102, 40% dos resíduos podem produzir cerca de 102 terajoules de energia por ano. Ora, isto é muita energia para ser usada, se isto é teórico, se na prática as indústrias pudessem processar. Eu ouvi esta manhã um dos oradores a dizer que era o Dr. Said, não é possível este processo todo correr sem o setor privado. Essas indústrias todas são privadas. Então, se nós olharmos claramente para a tendência, vamos ver que Moçambique não está muito longe dos outros países em termos de qual é a colheita de resíduos. E essa tabela mostra que a colheita de resíduos, se for feita apenas 25%, temos este cenário. Mas se for feita 50% dos resíduos que existem, portanto, se conseguimos recolher só 50%, o cenário muda de 102 para 172 no caso de energia que pode ser produzida por ano em Moçambique. Ora, podemos comparar com outros países, por exemplo, a Nigéria, que pode mudar de 486 para 824. Ou seja, como a indústria de agroprocessamento na Nigéria é muito avançada, claramente, olhando para os números, podemos ver que a colheita é muito elevada para a Nigéria, comparado com Moçambique, e por isso a quantidade de energia que se espera que até 2030 possa ser produzida, efetivamente seja produzida. Esta tabela mostra também que podemos diferenciar a energia primária, biomassa primária, que é aquela, por exemplo, na cana-de-açúcar, que pegamos o bagaço e metemos e produzimos energia, e também aquela que pode ser o conteúdo de energia que podemos extrair da biomassa. Eu vou pegar, mais uma vez, as indústrias açucareiras podem produzir etanol. Então, etanol é uma energia não primária. Portanto, é uma energia que, pelo seu processamento, converter, portanto, o resíduo do açúcar em etanol. E também estamos a acompanhar, o ministro da Agricultura veio um dia na imprensa dizer que há um esforço do governo para trabalhar com as indústrias de produção de óleo alimentar, as indústrias do açúcar, para passarem a produzir etanol. O país está a precisar de etanol e tem capacidade de produzir etanol, se olharmos para os números que estão aqui apresentados. Next slide, please, which is... next slide. Bart. Hello, Bart.
Yeah, I believe this is the next slide, right? Yeah.
Então, aqui é mais ou menos a mesma análise que fizemos anteriormente. A única diferença é que fala-se de rendimentos. Se o rendimento de produção agrícola aumentar, porque nesse momento é um certo rendimento, vamos pegar naquilo que está na moda hoje, a mandioca que produz cerveja. Se recordam, até 2012, a produção de mandioca por hectare em Moçambique era de qualquer coisa como... Alguém se lembra? 6? Não, mas 6 e há alguns quilos. Hoje, estamos a falar de produção, porque aumentou o rendimento da produção por hectare, está-se a falar de 15 a 20 toneladas por hectare. Ora, isto beneficia a indústria de produção de cerveja e beneficia outro tipo de indústrias. Mas aqui, outra vez, a comparação para o país, podemos ver as terras, a segunda coluna indica qual é a terra disponível para a produção em termos de hectares. Portanto, Moçambique tem 6,84 mil hectares disponíveis de terra para a produção. Temos um potencial de produção de cerca de 150 gigawatts por hectare, que este é o valor padrão que foi encontrado. Então, em termos de gigawatts ou petrawatts, podemos ter por ano cerca de 1.026 no caso de Moçambique. Mas em outros países, podemos ver que Moçambique é mais que a África do Sul, podemos ver também que Moçambique é um pouco mais que a Uganda, mas se olharmos daqueles números da segunda coluna para o último número, a penúltima coluna, vamos ver que o fato de nós estarmos a ter mais, por exemplo, que a África do Sul, não significa que estamos a produzir mais energia que a África do Sul. A África do Sul, por exemplo, está a produzir cerca de 735 em 2014 juros de energia, comparado com Moçambique, que estava a produzir, ou está a produzir, apenas até 30 megawatts por ano. O que significa que os empresários, mas os nossos técnicos do governo, podem muito bem, com este curso, tentar ver as técnicas, os métodos de cálculo que podem permitir interessar mais privados para, de facto, aproveitar o fato de nós termos, de facto, grande produção, muita terra e produção de produtos alimentares, mas não estamos a produzir energia porque nós estamos a aproveitar o desperdício e os subprodutos que aparecem. Ora, se olharmos para a tabela de baixo, iremos ver que a mesma análise que é feita em cima vem aqui embaixo e mostra claramente que Moçambique tem um grande potencial para a produção de energia, para a produção de calor e também para a produção de energia elétrica. Por outras palavras, Moçambique pode desenvolver a parte industrial que possa permitir alavancar a indústria de produção de energia com aproveitamento, vamos dizer, integral de energia produzida nas diferentes indústrias de agroprocessamento. É uma apresentação rápida, mas o documento que tem estas tabelas tem uma longa explicação de mais de 100 páginas de como nós podemos fazer isto. E uma das coisas que vamos fazer ao longo desta semana e ao longo dos meses que vêm é exatamente aprender a sair desta coluna para esta, como é que se chega, mas acima de tudo também podermos fazer projetos que podem ser bancáveis e podem ser muito úteis para o desenvolvimento do país. Muito obrigado.